This question comes from Bay Area JavaScript interview meetup on August 16th. Do a breadth first search traversal of a directed graph. Now the introduction is too long, so all I'm going to do is to go to the code straight away. So this is the graph. Let me do a visual representation. Okay, so you start off with the node with the value of 1. And your adjacent is your neighbors, means where your node will lead to. So you will lead to node 1, meaning there's a self edge. You will lead to node 2. You will lead to node 3. Now 2 will lead to node 5. 3 will lead to node 4. 4 lead to node 5. 5 lead back to node 2. The result of the breadth first search should be 1, 2, 3, 5, and 4 in a format of an array, where these are all integers. The reason being 1 is the starting node. Now 1 has a self edge because you cannot visit your node more than once. So we skip over, we go to 2, we go to 3. So that explains 1, 2, 3. Now 2 is at the front of the queue is earlier than 3, so we do 2 first. 2's neighbor is 5, so that explains 1, 2, 3, 5. Now 5 will lead back to 2 because 2 is already visited, we don't care. Does 5 lead anywhere else? No. Okay. Now does 2 have any more neighbors other than 5? No. Okay, then we go to 3. 3 has neighbor of 4, so that explains 1, 2, 3, 5, 4. Then 4 go to 5. Because 5 already visited, then we are done. The data structure is initialized as you have a key, where this key is a number, and you have an adjacency list. This is in the form of an array. In this array, we will store the data structure of the node, right? Your adjacency array will store the data structure of the node, whereas the key is just a number. Pause the video and see if we can solve it. This is a very basic graph question that tests BFS. Now, BFS always correlates to Q. I already gave it a hint in my walkthrough just now. Now, Q in JavaScript is an array, unlike C++ and other languages where you have a data structure for Q. So we have a Q, we have a result array that stores, and we return the result. Now we also need something that stores whether we have seen or visited a node before. Now we can use a hash table, call it seen. Now when you do a BFS, you will first enqueue. You can enqueue the starting node. So as of now, our queue will only have the node of 1, right, the starting node. And you push all the neighbors onto it. So you will have a while loop. Whoops. Before we push the neighbors, let us first examine the front of the queue. So we can call it front and pop the front of the queue straight away. So this will return the front. Now, if we already visited this node, we would ignore this node, right? So how do we know that? Seen.has. If we already seen this node, we just skip. By the way, I forgot to mention that every key of the node is unique. You cannot have multiple nodes with a value of 1, all right? So if we reach here, that means we have not seen this, so our result will push front.key. Then we enqueue the neighbors, right? How do we look through the array? We use for each. JSON dot for each. Oops. Now E stand for element. I'll just do Q dot push. Let's see what we got. I forgot to add what we seen. Yeah, now it's infinite loop. 1, 2, 3, 5, 4. Okay, there we go.